So conditional probability is that chain of events, right? One is dependent on another one, right? So we do define it like this. So say there is an event happening A, and then subsequently there is another event happening B, and then there is a subsequent event happening C, right? So now what is happening is that my this is first event which is sort of independent. So now this is what we will be calling, if you want to know the probability of this, we will be calling this as a probability of A event. Okay. Now when we come to B, actually it's coming from the chain. So this will be actually equal to probability of B given A is what we'll be calling. Since this event is happening after it's dependent on this, so we'll be calling this PB given A. Okay. Looking at this PC given B because now I'm depending on this one. Okay. So 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 how will this work out? And then what is the meaning of it? So now I was taking the case, say um the same case. Like for example, in this time around there are no three backs, but let's say there are four red and three white balls. Okay. Now what we are doing is that we are drawing the first ball. Okay. And then so the ball could be red or white. Okay. Now there can be a path here, red and white. Now again another ball, and then this ball is actually not replaced, is what I'm saying. So the case will be different when the ball is replaced. The ball is not replaced. If the red is drawn, then red is taken out. So now what I'm left with is three red and three white here in this path. What I'm left with here is four red and two white. Okay. Now again a red ball is drawn or a white ball is drawn. Not replacing. So now what has happened is this. And then second step again the same thing. So if I'm taking the red ball out and then this is actually now two red is remaining and three white would be remaining here. And here three red and two white would be remaining. Here too the step would be R and W. So there will be three red remaining here and then two white and there will be four red and one white. Okay. Now what's happening here? So let's go to this part. So someone is asking like if you are drawing in this manner, you are drawing two red balls is what he's interested in. The first is also red and second is also red. Okay. So what is the probability of drawing two red balls? All right. Now when I'm trying to write this, right? So I'm writing this. The first ball drawn is red. So the probability of that is I'm saying that PR1. Okay. So now this is an independent event. So there is 4R3W, right? So now my first event would be called this PR1. Okay. Drawing the first ball as red. And that would be actually equal to 4 upon 7. Now my second event is actually dependent on the first event. So it could be this round, right? And then I mean, we will look at that too. So I don't have to go this path because if the first ball is drawn is white, it's corner. I don't have to care about that. Then there could be two paths here. One it will go this side and this, wherein the second ball has to be drawn, right? So I want to travel this path. So now my second probability would be written as probability of drawing the second ball as 2, given that the first ball is the red one, right? Because it's dependent on that. It's not independently I can say that this is probability of drawing a second ball as red. If it's red, then this is also true. This is also true. That second ball is red here also, right? I'm drawing the second ball as red. But what I'm saying is that both the balls should be red. So the first one has to be red as well, and the second one has to be red as well. Okay. Here, when we are looking at here, this will be probably drawing second ball as red, given that the first ball is white, is what is the probability over here, right? So these two are different events now. Now here the idea is that this will become 3 upon 6. Okay. Now if someone is asking that both the balls would be red, right? So we are saying that this is the path we are looking at. Now the question is, should I be multiplying this, right? Is the question, right? So we are saying that this is what we are saying. That so what was the probability? R1 is the probability of drawing the first ball as red. What is the probability? I want R1 also and then R2 also. So this is what I want. This is what I'm saying. Uh, so what was R1? Probability of drawing a red, first red. What is R2? Probability of drawing a second ball as a red. And what is R1 intersection R2? That both is what we wanting. Okay. So my when I'm looking at this, what will be happening here is that we'll have to say that this is probability of R1. Okay. So this is what we want to know. And how do we calculate it? Now, this is what we want to calculate, and we don't know how to calculate it, right? So for that, what we'll be relying on this formula, ulta wala formula. So we'll be saying that, okay, how about this? Probability of R2 given R1. I know that. And then I also know that probability of R2 intersection R1, this will be equal to, and this will be actually equal to PR1, right? So it means that if you want to make sure that both the events happen together, then their probability have to be multiplied. So this is what they are looking for. Okay. So here 4/7 into 3/6. So now whatever comes will be your probability will be 2/7. Okay. So this is a conditional probability in action. Okay, when they were explaining your conditional probability using example of throwing a dice and then saying that if it is 2, 4, 6, then what will be this? So that is more like in one event itself we were trying to look at as to what was happening, but we were trying to just explain the concept, but actual application of it is here, wherein there is a sequence of events happening and one event is dependent on the other one. So in such cases, this is the correct meaning. You can understand what is written here. It means that this is actually R2 is actually dependent on R1. This R2 is actually dependent on one. But what I'm needing is this one, wherein the first one is R1 and the second one is R1 as well. I mean, the red as well. Okay.